Hey Chemistry, Mrs. KJ here, going over 1.03, Matter and Energy. Matter undergoes changes with the help of energy. Matter can be found in three basic forms or states: solid, liquid, and gas. Adding or subtracting energy from a system can cause a change from one state to another. So in other words, if you want to go from a gas to a liquid, you have to change the energy. Matter can undergo both chemical and physical changes. A chemical change produces a different type of matter, whereas a physical change does not. So with a physical change, you're still going to end up with the same substance that you started with. Goals for this lesson. Define the goals of matter and give examples of gases, liquids, and solids. Compare and contrast a physical change with a chemical change. Identify the role of energy in chemical and physical changes. Matter exists in phases including solid, liquid, gas, and plasma. Although we don't talk a lot about plasma, it does exist. For example, in the stars. So again, for example, sun and lightning. Those are two examples. So again, you can go ahead and get the student guide. Matter has mass and volume. Energy is the ability to cause change. The differences between a candle and a flame illustrate the differences between matter and energy. When you pick up a candle, you can feel its mass and volume. So mass, basically how heavy, and volume, how much space it takes up, both of which you can measure. Matter is the stuff of our world. The flame gives off heat energy and light energy. The energy does not have mass or volume, but it melts the wax and can light the room. One definition of energy is that it is something that causes a change. Thermal energy, so heat, light energy, and sound energy are all different forms of energy and all have the capacity to cause change. Watch the video to see the changes in the flame as the candle burns and then is blown out. So again, you're going to have to go back to the lesson yourself and watch the video because I can't get the sound to play over these. And then from the study guide, I left the beginning paragraph, the goals, our keywords and pronunciations, which we'll come back to. And then I started with the notes here that matter has mass and volume, and energy causes change. Matter exists in three common states: solid, liquid, and gas. Again, there's plasma, but like they said, these are the common ones. So water and other forms of matter can exist in three states: solid, ice. And for solids, solids have a fixed shape and fixed volume, meaning that the solid keeps the shape that it's in and it takes up the same amount of space. So your computer always takes up the same amount of space on your desk every day. Your desk takes up the same amount of space in the room every day. The room takes up the same amount of space in your house every day. That's fixed volume. If we look at liquid, liquid changes shape. You know that liquid will change to the shape of the container. If you have it in a cup, for example, or if you spill it on the floor, it spreads out, but it still has a fixed volume. 1 cup of water inside of a glass is the same amount as 1 cup of water on the floor. So the amount or volume stays the same, just the shape changes. And then you have gas. Gases change shape, so it spreads out to fill up the container. And it also changes volume. Again, it's spreading. And that is why when you light a candle in one room, pretty soon you can smell it in the next room because the gas molecules are moving around. If you consider this iceberg on the ocean under a cloudy sky, you will see that matter exists in three states. Although the iceberg, the ocean, and the clouds are all made of water, they are somewhat different. The iceberg is rigid, has a definite shape, and occupies a definite amount of space or a fixed volume. It is a solid. The water is fluid, meaning that it does not have a definite shape, but it does occupy a fixed volume. It is a liquid. The water vapor of the air expands to any size and shape. Water vapor is water in its gaseous state. Steam. Many people in some textbooks refer to steam as the gas state of water, but steam is actually liquid water in the form of microscopic droplets. The air contains a lot of water at all times, but it's in the form of water vapor. Water vapor is the correct term for the gas state of water. So I added to our notes the states of matter: solid, fixed shape and volume; liquid, shape changes but fixed volume; gas, shape and volume changes; And I just listed plasma as the fourth to remind you that, yep, there is the fourth state of matter. Matter can also exist in a form called plasma. A fourth state of matter, plasma, is similar to a gas, but instead of electrons being attached to molecules, as they are in a gas, electrons in plasma are free to move. Plasma makes up the sun and occurs commonly on Earth as lightning. It's even found in neon and other fluorescent lights. Plasma shares some properties with gases, but gas and plasma are very different. For example, both are free to move and fill a container, but because the electrons in plasma are free, they can conduct electricity and can be controlled by electric charges. So plasma glows in neon lights. The sun is composed of plasma, and plasma glows in a fluorescent light. So for plasma, I added electrons are free to move, not connected to molecules, and then I gave the example of sun, lightning, and neon lights. There are many examples of solids, liquids, and gases. You just learned that water is a substance that exists as a solid, liquid, and gas. Now look at some other substances. Most metals, such as gold, silver, aluminum, nickel, and iron, are solids at room temperature. Charcoal and granite are solid forms of carbon. Examples of liquids include alcohols, gasoline, crude oil, vegetable oils, and even, at room temperature, the metal mercury. Common gases include nitrogen, oxygen, hydrogen, helium, and neon. To determine if a substance is a solid, liquid, or gas, ask yourself these questions. When placed in a container, does it have a fixed volume? Does it have a definite shape? If the substance does not have a fixed volume, it's a gas. If it has a fixed volume and definite shape, it's a solid. If it has a fixed volume but not a definite shape, it's a liquid. Now, obviously, I know you can tell if something is solid, liquid, or gas by looking at it, but in the test questions, they're going to base it off these definitions. So make sure you know them. So metal gold is a solid. Mercury, which you may have heard of in the old thermometers, is a liquid at room temperature. And neon is a gas. Matter can change states, and those changes are accompanied by energy changes. If you hold an ice cube in your hand, it will melt. Melting is a change of state from solid to liquid. Melting requires energy in the form of heat, that is, thermal energy. If you collect water in a pan and let it sit at room temperature, it will eventually evaporate, that is, change from liquid to gas. Melting, boiling. Boiling happens at a certain temperature. Remember, you have to get the pot really, really hot before the water will boil. But evaporation happens at any temperature when you have a liquid because the water molecules at the top are bouncing around and some of them bounce free and become gas. And you also have vaporization as well. So I added your phase changes: melting, solid to liquid, boiling or vaporizing, they mean the same, liquid to gas at certain temperatures, evaporation, liquid to gas at all temperatures when you have a liquid, condensing, gas to liquid, freezing, liquid to solid, sublimation, solid to gas, like dry ice, and deposition, gas to solid, for example, frost. State changes involve adding or absorbing energy. If you want water to evaporate faster, you can heat it to boiling, add energy. By contrast, if you cool water vapor, you will condense it into liquid water. If you place water in a freezer, it will turn to ice. Both of these changes involve removing thermal energy or heat energy. Watch the video to see how various substances are changing from one state to another: solid to liquid, liquid to gas, gas to liquid, gas to solid. Again, you are going to have to go back to your lesson and watch the video. You can pause and do that now, or you can do it at the end. Adding or removing energy changes the movement of molecules and can change the state of matter. Consider what happens when ice is heated. In ice, the water molecules are attracted weakly to each other and are held in an ordered crystalline structure. For example, think of how snowflakes look. The molecules don't have much energy and they only vibrate rather than move. So they are still moving, it's just that they're just vibrating back and forth. As the ice is heated, the added thermal energy causes the water molecules to vibrate faster, break the weak attractions that hold them in crystals, and move somewhat freely. So now ice melts into liquid. As the liquid is heated, the water molecules move even faster. Finally, when the liquid boils, the added heat energy causes the water molecules to move fast enough to break free of any attractions from other molecules and to escape as water vapor or gas. The reverse happens when water vapor condenses to liquid water and liquid water freezes into ice. The easiest way to keep straight whether or not a phase change is adding or removing energy is to think of the speed of the molecules. Slow solids, medium liquids, fast gas. To go from solid to liquid to gas, the molecules are going faster and faster. To go faster, you need to add energy. You know that if you want to run a race, you need to add energy to your body to run. We need to add energy to the molecules to get them to change from solid to liquid to gas. Down here, they're already gas. They're going crazy, moving all over, but they want to slow down to a liquid and slow way down to a solid. So the molecules are slowing down, which means they release energy. They have less energy. They let the energy go. There are different types of energy. As mentioned earlier, energy is that which can cause change. You have seen how thermal energy can cause changes in the state of matter. There are some other types of energy besides thermal energy. Remember, thermal energy is heat energy. Here are some kinds: mechanical energy or movement, radiant energy or light, electromagnetic, like from the sun, electrical energy, sound energy, chemical energy. Energy can change from one form to another. For example, in a battery, chemical energy changes into electrical energy. In a light bulb, electrical energy changes into radiant or light energy. Fire gives off radiant energy and thermal energy. Energy and work. Energy is often defined as the ability to do work. In physics, work involves applying a force through a distance. And so I added the types of energy to our notes. Physical changes do not alter the identity of matter. Consider changes of state such as ice melting or boiling water. The water molecules before and after the change were not changed themselves. They're still water molecules. So what's the abbreviation or formula for water in chemistry class? H2O. So water is H2O, whether it is ice, H2O liquid, H2O gas. It's always H2O. You change the form, but not the substance, and that's why we call it a physical change. Similarly, if you break a piece of wood, you have two pieces, but each piece is still composed of wood molecules. If you saw or grind a piece of iron, you still have iron molecules before and after. This type of change where the atoms or molecules are not changed themselves is called a physical change. Physical changes include all the changes of state, such as melting, boiling, condensing, and freezing. I always say phase changes are physical. Any change that reshapes the substance is a physical change. For example, when you mold clay or putty, you change the shape, but not the substance. Breaking a glass also changes the shape, but not the substance. Bending a paperclip is a physical change too. Breaking glass, it's still glass. When water freezes, it's still H2O, therefore it is a physical change. So up in our vocabulary words, physical change, change to a substance that does not alter its chemical composition. So in other words, you have the same substance before and after. Examples, all phase changes are physical. Bending, breaking, and folding are also examples of physical changes. Chemical changes alter the identity of the matter. So now we're going to make something new. Think about what a match looks like before and after you strike it. Is it the same substance? No. It has some heat release, you have some smoke, you have the ash. You could never get back that original match. That's a chemical change. Now, some chemical changes you can get back to the original by doing another chemical change, but either way, at some point you create a different substance with a different chemical formula. If you spray an iron nail with water, the nail will eventually rust. The iron atoms in the nail combine with the oxygen and form rust called iron oxide. This type of change, where the atoms or molecules before the change are different from the ones after the change, is called a chemical change. When a match burns, the wood molecules change into different molecules, including charcoal. When a bomb explodes, the chemicals in the bomb change into gases and expand rapidly and violently. Like physical changes, most chemical changes are accompanied by changes in energy, usually in the form of heat energy. Okay, my time's going to run out because I can only do 15-minute videos at a time. So there's going to be a part 2, and we will pick up right here in this last paragraph. So go ahead and make sure you watch that.